Good morning, students. Today we'll start the next chapter. So we see that we in the previous chapter, in the fundamental of statistics, we discussed about the data, how to collect it and represents the data in graphically and tabulated form, and also we know the distribution of the data. There are three types of distribution. One is simple distribution, two simple frequency distribution, third is group frequency distribution. Now, for statistical purpose, we have to find, you can always find that in each of the tabulation of the data, the frequency of the values at the beginning and at the end are very small, and the middle part of those values, the frequencies are mostly high. Okay, so this behavior of the statistical data with regard to the concentration of the values in the central part, okay, of the distribution, this is called the central tendency, okay, or the averages of the data. So total, there are many types of averages. These total averages are connected in the simple form, which are central tendency. Okay. Now, the types of averages. Mostly three types of averages are very important. One is arithmetic mean, second median, and mode. And also there are two averages. One is geometric mean and second is harmonic mean. Okay, also can be calculated. Okay, so mostly we will use the arithmetic mean, which will be simply known as the mean, and median and mode. Okay, today we will discuss the arithmetic mean and geometric mean and harmonic mean. Okay, so arithmetic mean. The arithmetic mean is the simple averages of the variable. Okay, for a simple distribution, the averages of the values is called the arithmetic mean. Okay, and for simple frequency distribution, which will be also known as the weighted arithmetic mean, there is a formula to calculate the weighted arithmetic mean. We'll show. Okay. Now, arithmetic mean, which will be known as the AM, okay, denoted as AM. If x1, x2, x3 up to xn be the n values for simple distribution, if be the n values, then the arithmetic mean AM will be x1 plus x2 plus sum of all the values divisible by total number of observation, which is n. Now we will denote these numbers by using the notation summation, which is also known as the sigma. Okay, summation means sum of the numbers. Okay, here I equals to runs from 1 to n. When I equals to 1, x1, when I equals to 2, x2, and for 2 each and every values of I, there will be a sum. Okay, which simple form, this is the simple form of arithmetic mean. Okay, so if the values of n observation is given, then the arithmetic mean will be the averages of the number, and the form is, this is the form. Okay, and this is simple arithmetic mean. Now weighted arithmetic mean means, next is weighted arithmetic mean, weighted AM. Weighted means if two values are occurring, if one value is occurring many times, that is when the frequency is given. Okay, that is x1 happens 2 times, x2 happen 5 times, x3 happen 6 times. Okay, so when the frequencies is given, that is the weight x1 happening many times, x2 happening more than 1 time, then the weight of x1 will be, if x1 happen 3 times, then weight of the x1 is 3. Okay, So then we have to calculate we have to consider the frequencies also. So if a given data, for a given data, let x1, x2, x3 up to xn be the n values, and the corresponding frequencies are f1, f2, f3 and fn. So total number of observation will be, total number of observation jodi n, if we say n is the total number of observation, then the n equals to f1 plus f2 plus f3 up to plus fn, that is summation fi. Okay, this is the total number of observation. Okay. Now for weighted arithmetic mean or for simple frequency distribution, the arithmetic mean will be am equals to, the values will be multiplied, each of the values will be multiplied its frequency and summed up. Okay, so x1 f1 plus x2 f2 plus up to xn fn divided by total number of frequency, which is n, that means f1 plus f2 plus f3 plus dot 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 fn. Okay, so either this or this, either this or this. Okay, so this can be also represented in the simple form using summation I equals to 1 to n xi fi. Okay, so this is the simple frequency distribution. This is the am for simple frequency distribution. So we find that for simple distribution there is no frequencies, then the arithmetic mean is simple averages. For weighted arithmetic mean, if the frequency of the each value is given, then the arithmetic mean will be found using this formula. Okay, next for group frequency distribution. Grouped frequency distribution. As for group frequency distribution, the values are given in the interval form, so there is no exact value for the each frequency. Okay, right? That is when a group frequency is given, so there is a class interval. Okay, class interval and frequency. Now to calculate the arithmetic mean, the group frequency distribution can be represented as the simple frequency distribution. Let's say there is a class marks x1 to x2. Okay, then x2 to x3, then x3 to x4. So these are the class interval. Okay, x1 to x2, x2 to x3. The frequencies are f1, f2, f3. Right? This is a continuous interval. If the values are not in the continuous interval, then we will make it continuous interval by using the averages, adding and subtracting the averages from the first interval to second interval and second interval to third interval. If they are in the class interval form, then the class, if they are in the continuous form, then class interval can be represented as the class boundaries. Okay, now to calculate the arithmetic mean for group frequency distribution, we will use the class mark. Now you know what is the class mark. Class mark is the mid values of each of the interval after changes it in the continuous form. Okay, if this is in continuous form, the mid values, if we say the mid values is for this part is y1, this part is y2, this part is y3, then class marks is y1, y2, y3. These class marks will be taken as the variable values of the variable. Okay, so for a continuous group frequency distribution, the arithmetic mean will be taken as the simple frequency distribution, where frequencies are these and the values are the class marks of each interval. Okay, so the arithmetic mean will be y1 f1 plus y2 f2 plus y3 f3 plus up to yn fn divided by f1 plus f2 plus f3 plus up to fn, which is can be written as summation yi fi divided by n, where n equals to summation of fi, total number of observant. Okay, so this is the formula where yi is the class marks of each interval. Okay, so we see that the arithmetic mean, we will find the arithmetic mean for simple frequency distribution by using this formula. Group frequency distribution, for simple distribution this formula, for simple frequency distribution this formula, and group frequency distribution we changes it in the simple frequency distribution by taking the values of the variable of the as the class marks. Okay, so in this way we will calculate the arithmetic mean of each of the case. Now next is geometric mean. What is geometric mean? Geometric mean means if the values geometric mean. Okay, now geometric mean and harmonic mean are not important. We will just calculate it to understand the meanings of geometric mean and harmonic mean, and some simple questions to solve. Okay, for the next, after median, mode and dispersion, we will use only the simple only the arithmetic mean, okay, which will be considered as mean. Okay, now x1, y1, x1, x2, x3, x4 are the values of an n values, okay, n observant values. Then geometric mean, which will be represented as gm, is calculated by this form: x1 x2 into x2 into x3 up to xn whole to the power 1 by total number of observant. Okay, in this way we will calculate the geometric mean. Now weighted geometric mean, to calculate the weighted geometric mean, as if x1 x2 x3 up to xn be the values corresponding with the frequencies f1 f2 f3 up to fn, then gm of the weighted geometric mean will be x1 to the power f1 into x2 to the power f2 into x3 to the power f3 xn to the power fn whole to the power 1 by f1 plus f2 plus f3 plus up to fn. Okay, which will be calculated as x1 to the power f1 x2 to the power f2 into x3 to the power f3 xn whole to the power fn whole to the power 1 by n equals to summation fi. Okay, so this is in this way we will calculate the geometric mean and weighted at geometric mean. Okay, next is harmonic mean. Now most of you know the harmonic progression. Who knows the harmonic progression? She knows the what is harmonic mean. Now those who didn't know the harmonic progression, they simply know that if x1 x2 x3 are the values, n values for simple distribution, n values, then harmonic mean will be calculated as the arithmetic mean of the reciprocals of the values. That is, the reciprocals of these values are 1 by x1, 1 by x2, 1 by x3 up to 1 by xn. So to calculate this harmonic mean of the given values, first we will calculate the arithmetic mean of this part. So arithmetic mean of the reciprocals are 1 by x1 plus 1 by x2 plus 1 by x3 plus up to 1 by xn divided by n. Okay, that is summation 1 by xi divided by n. So the harmonic mean, which will be denoted at hm as hm, equals to the reciprocal of the arithmetic mean of the reciprocals values. Okay, that is n by summation 1 by xi. Okay, so harmonic mean is the reciprocal of the arithmetic mean of the reciprocals values, right? So this is the formula for finding the harmonic mean. And for also weighted harmonic mean, if x1, x2, x3, I'll directly and corresponding to f1, f2 up to fn, just I will use just taking the formula as it is given, which is harmonic mean equals to capital N divided by f1 by x1 plus f2 by x2 plus f3 by x3 plus up to fn by xn. So this is the arithmetic mean of the reciprocal values. So harmonic mean will be just the reciprocal of the arithmetic mean, right? Which can be written as capital N divided by summation fi xi. Okay, and which is where n equals to summation fi, total number of observers. So this is the total harmonic mean, this is arithmetic mean, geometric mean and harmonic mean. So there are many questions I will be doing. First I will be discuss the relation between harmonic mean, AM, GM and HM. AM means arithmetic mean, GM geometric mean, HM harmonic mean. Now to find the relation between AM, GM and HM, we will consider two values. Okay, we will consider two values, let x1 and x2, and consider the simple distribution. Okay, for simple distribution, let's say there are two values x1 and x2, then AM will be x1 plus x2 divided by 2, GM will be x1 into x2 whole to the power 1 by 2, which can be written as root under x1 x2, and HM equals to 2 by 1 by x1 plus 1 by x2. Okay, which can be written in this form after taking the LCM, 2x1 x2 divided by x1 plus x2. Okay, now here we will start with consider the value root under x1 minus root under x2 whole square. Whatever we know that all the values of a statistical of a given data x1 x2 are taken positive. Okay, so root under x1 minus root under x2, whatever be the value, as there is a square, this value always greater or equals to 0, right? Now after expanding we will get a square minus 2ab minus b plus b square. So x1 minus 2 root x1 root x2 plus x2 greater equals to 0. So x1 plus x2 greater equals to, taking this part in the right hand side, 2 root x1 into root x2. dividing 2, x1 plus x2 divided by 2 greater equals to root under x1 into x2. Now this is the arithmetic mean. Greater equals to, this is the geometric mean, GM. This is first part. Okay. Now to find the relation of GM and HM, we take the next relation, 1 by x1 root under minus 1 by x2 root under. This is square, which will also give also the greater equals to 0. After expanding, we will get 1 by x1 plus 1 by x2 minus 2 1 by x1 root under into root under 1 by x2 greater equals to 0. Taking these two part in the next part, 1 will be get greater equals to 2 by root under x1 into x2. Okay. Now taking LCM, we will get x1 plus x2 divided by x1 x2, right? Okay. Now taking inverse, okay, we know that if A greater equals to B, if we take the reciprocal 1 by A, always the sign of the greater than sign will be inverse, will be taken as less than sign 1 by B. Okay. So here if we take the inverse 1 by x1 plus 1 by x2, okay, root under 1 by 2 by root under x1 x2, then this sign will be less equals to, that implies 1 by x1 plus 1 by x2 less equals to root under x1 x2 divided by 2. Now multiplying 2 in this part, 1 by x1 plus 1 by x2 less equals to root under x1 into x2. So this is the HM, less equals to, this is GM. That implies GM greater equals to HM. This is second part. Now for one part we get AM greater equals to GM, and this part we get GM greater equals to HM. So taking 1 and 2 together, we will get AM greater equals to GM greater equals to HM. Okay, this is the relation between arithmetic mean, geometric mean and harmonic mean. Now if all the values x1, x2, x3, x1, x2 are same, as we can take as x1 equals to x2 equals to, let's say, x. Okay, then AM will be x plus x divided by 2, which is x. GM will be root under x into x, which is x. HM will be 2 into x divided by x plus x, which will be only x. Okay, 2x square divided by 2x, 2 x. Okay, we get AM equals to GM equals to HM. So this is the case for all the values. If all the values of the data of a given value variable, then the arithmetic mean, geometric mean and harmonic mean will be same. Okay. Also there is a relation, we can prove that. I just write the relation, you can try it at home. Second relation, which is AM into HM equals to GM square. Okay, this is the homework for you to calculate it at home. Okay, simple way, just take the two values, two variable x values of the values, two values, okay, x1 and x2, then calculate it AM and calculate HM and calculate GM, then right hand side, show the right hand side and left hand side. Okay, just you can find it very easily. Okay, so there are two relation, AM greater equals to GM greater equals to HM, and the AM into HM equals to GM square. Okay, Using these two relation, we will solve many question for the in the next class. Today, that's it for today. Just study it. I will be sending a PDF. Go through it, and there is many example to find the arithmetic mean and geometric mean. Okay, solve it, practice it at home. I will do the next part and some questions. Okay, that's it for today. Thank you.